Okay, great. Well, hello and welcome. Thanks for coming to this session. We're going to talk about how to use OPeNDAP to access data. And in particular, this session is going to focus on data that NASA serves in its newly and being developed cloud data system. My presentation today is being sponsored by Raytheon, who is the subcontractor who's developing that system. Yes? Move closer. I think so, yeah. Okay. So this presentation is sponsored by Raytheon, who's a subcontractor to NASA developing this system, and OPeNDAP is the contractor, rather. Raytheon is the contractor. OPeNDAP is the subcontractor. But my other role is that I'm the president of OPeNDAP. OPeNDAP's a not-for-profit corporation that was formed in 2000 to develop software to make data access and subsetting over the network easier for people. So thank you, welcome, and hopefully I can advance the slides. He writes software, but can he use PowerPoint? Okay, so what is it about OPeNDAP? Well, I've already given away some of it, but so OPeNDAP is a way to access data from various sites on the internet. And in particular, OPeNDAP provides these tools to not only access the data, but subset the data. And that's really important for large data sets like the ones that NASA has, which can have hundreds or thousands of variables in them. And oftentimes when you're working with data, you only want 4 or 5 variables. You want sea surface temperature, or you want the U and V components of wind vectors, and then you want the latitude and longitude domain information that goes along with those. You don't want the 200 other variables in there that are just as big as the sea surface temperature variables, but that have to do with the satellite calibration. That stuff's important, we all understand that, but a lot of times you just don't want it. So that's what the deal is with OPeNDAP in a nutshell. But what I'd like to know is I'd like to know some things about you guys, because it's actually been quite a while since I've done one of these tutorial sessions. And I want to find out where we're all at in terms of the kinds of things we're going to be looking at and the tools that we'll be using today. So can you tell me, like, this is a show of hands type of poll. This is the low tech poll, like we're, in like elementary school or whatever. So do you primarily consider yourself a researcher who uses data? Are there any researchers here? Okay. Couple of researchers. All right, great. What about, are you a system developer? Okay, system developers, great. And what about a data manager? Are you a data manager? A lot of data managers. What about a teacher? Are you guys teachers? Is there anybody I didn't get who wants to just shout out what they do? Okay, well, I don't know what I do either. Right now I stand up here and I ask questions. Okay, well, we can maybe talk more later. So here's another hand-raising question. Do you use NASA data? How many people here use NASA data? Okay, cool. Have you ever used Jupyter before? Do you know what Jupyter is? All right. And then what about GitHub? Lots of GitHub users, wonderful. Okay, so before we dive into the tutorial, so this is the end of the talking points, okay? What we're gonna do from now on is we're gonna work with Jupyter Notebooks. But before we do that, what I think would be really good is if we formed kind of small groups. You don't have to, but if you want to, that'd be great. And if you're sitting next to somebody, how about if you just talk amongst yourselves and discuss what you plan to get out of this tutorial. Why are you here? What do you want to learn from this? And let's spend 3 or 4 minutes just talking amongst yourselves about that.
4 minutes.
Excellent. And this will give me a chance. Do you know how I can make this tab thing go away?
Yes.
Thank you. Oh, great. And I can just press escape if I need to get to the controls.
And then we'll make sure the focus is back on.
Cool. Thanks.
So after this, you could, if you want, ask people to volunteer. A couple people to what have you heard? Like, what's a learning goal you've heard from somebody else? Yeah.
Okay.
And if someone volunteers, you could ask for another one, and just do 2.
Okay.
It's nice to hear.
Cool. And I'll inform Carl. Thanks very much. I'm going to introduce you guys. So that they know what's going on. Look, people are actually doing that.
It's running workshops like this.
I actually have not been to an in-person event for a long time, but I work with some really great facilitators who have taught me a lot. So I do a lot of thinking about managing groups and getting people to participate and talk to how to interact and try things, and some things fall flat.
Right.
But I've got a friend who's like she's like an elementary school type of like interactive participant person, and she's really creative. The most creative person I've ever met with. So I've like her, and some of it's a little too like participatory.
Right.
But you could talk to me. So just thinking about being a journalist in the room, basically by training a graphic designer that didn't have any background in data. That's probably the type of person you could be talking to. Kind of the low. Well, I heard one person walking by, I heard someone say, I've never used that. I've heard about it. There's somebody in the back. Something I've done before then too is just kind of walk around and try to just talk to people about kind of like what the person yesterday I was talking to at the like conversation, kind of just generally browse to help so you understand the audience. Over 35 seconds. It's going to be hard to get people to listen. I don't have a lot.
Oh, well, I have.
So you could just begin and just say, like, in about 30 seconds, we're just going to, if you want to wrap up.
All right, in about 30 seconds, we'll start the tutorials. Hello. So I think we're gonna move on here. Thanks very much for going along with that exercise. Is there anybody that heard a goal that they want to share or has a goal that they'd like to share? Are we all shy? No. Okay, we're not shy.
Thanks, Dan. Nick Lyon, LTR Network Office. I think one of my goals is, so far when I use NASA data, I've been using the Appears portal.
Okay.
No complaints about that, but it does sort of offend my aesthetic sensibilities that my workflow is scripted except for the data acquisition phase.
Okay.
And so I'm hoping that this lets me sort of make everything code.
I think we're going to satisfy that goal. Is there anybody else?
Madison Langseth, USGS. Basically to feel less stupid when people talk about OPeNDAP.
Well, okay. So the goal, of course, of OPeNDAP is not to make anybody feel anything other than happy. So I hope we can meet that goal. Anybody else? Great.
Hi, Amanda Lovett, Florida State. I think part of what our group sort of talked about is we kind of just want to get a better sense of what OPeNDAP is and can we apply it to the kinds of data that we're working with.
Okay, great. Okay, let's dive into some stuff. So first off, as I said, this workshop is primarily highlighting the data that NASA provides. And I want to also, I've been remiss, I want to introduce my two colleagues, Chris Battisto and Enrico Berponze. They're going to help with this session. And Chris has written some of the notebooks that we've got in our collection. We have a collection of 6 notebooks, 4 that were authored by folks at OPeNDAP to illustrate basic concepts, and then 2 that have actually been contributed by the DACs. And it turns out that you can find many things like YouTube videos and Jupyter notebooks and R notebooks and all kinds of things like that on the web that talk about various uses of OPeNDAP. I just selected 2 here, and we're going to be highlighting 1 because it reads data from this new cloud data system. And you know, that's the new thing, and we want to show that, right? So, but we will get into places in the tutorials where I talk about, oh, you know, you don't have to necessarily use stuff from the cloud, and I'll talk about how the same code could pull data from different kinds of servers running in different contexts. But before we start any of that, we need to have everybody or the groups of people have an Earth data login that they can use. Now, if you've decided to work in a group, you probably just want to have one person have the login, and so you all need to have an Earth data login. How many people here already have an Earth data login that they can use? Okay, so everybody that didn't raise your hand, we're going to need to get you one of those. So the first thing to do is to go. I'm going to go here on the screen, and I'm going to go to this site, urs.earthdata.nasa.gov. And if you can go to that site on your computer, it's kind of tough for me to show you this because it's a single sign-on system. So once I've been there, I'm signed on. Actually, I can sign out. But you go there, and there's a registration button. So this is what it will look like for you if you don't have an account. You have this registration button. So I think. It's been a while. So you click the registration button and you type in your username and type in a password. And if you're creating that, and I apologize for y'all that already have these, but if you're creating that, pick a username and a password that's reasonably secure password, but make it something that you can easily remember or write down, because you will be using it again in this session right away. And this is one of those sticking points, so we want to make sure that everybody is caught up and has this account information. So if you have any issues with getting the Earth data login, let us know right away, and we'll come and help you. Right. So the URL, once again, is urs.earthdata.nasa.gov. And you go there, and if you don't have a login, there'll be a register button. Click on the register button. You'll see this screen, and you will get an account. The account is given to you automatically. There's no approval process or anything like that. Anybody can get one of these accounts. It's just to track you so that later on the government can come after you. No, that's not true. That's not true. The government will not, well, they may come after you. I really can't control that, but probably not for this reason. So how's progress going on that? Is anybody still working on the Earth data login? Some people are, okay. Let's check. We do have people online. Okay, great, thanks.
Chris is gonna get on the Zoom call today.
Ah, wonderful.
Manage that.
Yeah, how do I make this go away again? Oh, okay, all right. Yeah, there you go.
How's everybody doing? We're all good? Yeah.
Everybody's good, great. Well, I mean, you're all good, yes, but you also have an Earth data login. Wonderful. So the next thing we're going to do is, so now I'm going to have to log in, and I'm going to log in as my special user, whose name is tutorial1. Oh, this is not what I wanted to do, is it? You know, it's like anytime you use a computer that's like different than the one you're used to, your typing kind of goes out the window. So there's a second step that you need to do. And that's when you have an Earth Data Login account, in order to access data from within the cloud system, you're going to need to approve the application that essentially logs in on your behalf to some of the underlying data systems. So we're going to go to this applications menu right here. And so you're at this page, so you need to click on this, and where it says Authorized Apps, you're going to authorize the data server, the OPeNDAP data server that's in the cloud. So go there and click on that, and it will show you these things. The fabled Authorized Apps. Why it's not doing that, I don't know. Oh, it's just spinning. Go to Applications and click on Authorized Apps. I don't know why it's not working. Really?
Yeah.
I can't. I don't know.
I get 500 internal server error.
Really? Wow. Well, we shouldn't be taking down Earth Data Login. This should work. Wow.
So if you've gone into this approved application, there's 5 selections that you'll want to click approve more applications.
That's right. And then if you can search for something called Hyrax, Hyrax, and you'll see Hyrax in the cloud as a list of one of the potential choices, and you want to approve that application. RAX. It's called Hyrax in the cloud. Yeah, you need to type the Hyrax in the cloud into the search bar, and then it should appear in the list of applications that you can choose.
Some people show edit, some people show you can approve, some people show not edit.
So, yes. So, yeah, so some of you may already have this.
You're still getting an error sign.
Yeah, I'm still getting it.
Oh, now I get a 502.
Yeah, I'm not sure. Maybe it's, is there another session that's also requesting Earth Data logins at the same time? Huh. All right. No, you want Hyrax in the cloud.
Yeah, there's a very good chance this is related to the hotel network. On my cell phone, I get access to that 4G,
Yeah, we may have, I mean, what may be happening is we may be saturating the Wi-Fi because there's another session that's doing the same thing that we're doing right now. So that's a drag. So.
James, for some of us that are just getting it.
So somebody shared that using a VPN also helps get past that. Okay, past that. Oh, so using a VPN might also help you get past the error message? So if you're able to get into the approved applications page, then you should approve more applications. There's a blue box at the bottom. So click that. Work. And then when you get to that page that says approve applications, you're going to put in Hyrax in the cloud. Hyrax, Hyrax. don't have VPN, huh? I don't have.
I was like 3/4 of my way.
It was very hard. It was very heartening. I think that seeing like art with data, seeing data turn into art, it's just amazing. I think it warms every scientist's heart. And clearly your passion for doing it, I think, really came out in the talk. Who is still here having trouble? Okay. Do any of you have the VPN? A VPN that you can use? No, I don't either. So.
I left the network.
You're in?
Just my own network. Since we get to they just
see like people bombarding it. You can also leave the network and try to rejoin just to see if it refreshes it for you. Yeah, so if you're still having trouble and you're on the hotel Wi-Fi, it might be something where if you leave the network and rejoin, and or if you have a mobile hotspot that you can activate just for this part, it might be just that it's getting bombarded, and it might be like a DNS. Potentially, because it might give you a different IP from the cell tower.
Oh, so you're in. Okay, great. All right, so Hyrax in the cloud. Looks like you're approved already. Okay. I think that's, I think we're going to stop, pause here.
I can't see with my mouse.
So who here still has an error message and would like to proceed? Do you mind helping them out?
Okay, so that took 2 minutes. How are we with getting the EDIL account and approving Hyrax in the cloud? We're good. A lot of thumbs up. Okay, so now there's kind of one more step that you have to do, and then it's a little bit more straightforward after that. One hopes, anyways. So in a browser, type in github.com/OPeNDAP in all uppercase letters, and you'll go to the page that you see up here, which is our GitHub repository, and we'll be running the notebooks off of the GitHub repository. So, and this, by the way, this GitHub repository is going to persist, and hopefully we'll add more and more to it over time. And you can go back, and there are 6 notebooks here now. We're going to go through 2 of them today. You can see that things move a little more slowly in a room like this with a very congested network, but we're going to go through 2. And so when you're here, let me know. Okay, you're here. So what you want to do is one of the pinned repositories in the lower right corner is called the NASA tutorials. So let's click on that and go there, and you will see that you begin. There's Sure. Yeah. So when you get there, click on this tutorials link right here, which is the third link down from the top. And when you go in there, we're going to run our notebooks in a virtual environment called Google Collaboratory, or just Collab for short. And there's a folder that's the second one down called Collab. There's another folder called Binder. I think we have way too many people and way too much network activity to run Binder. So we're just going to go with Google Collab for this. So click on that folder that says Collab. And then we're going to go down and we're going to skip over the first 3 notebooks and go right to the one called PyDAP DAP4 Basic that I'm highlighting right now. It's actually got a 3 in front of it because I'm a computer guy and I start with 0. Sure. Is that better? It's somewhat better. Okay, great. So let's go into that notebook. So if we click on it, one of the first things that's going to show up is this thing that says open in Collab, a little badge. And we can click on that. You can right click on that and it will open it in a tab in your browser, or you can just click on it. But I'm going to right click on it so that I can go back and forth, because we've learned that Murphy is definitely in the room today. Okay, so this is the first of these notebooks, and let me give you a little overview about what this notebook does and why I'm having you look at it. So remember I said that OPeNDAP is a protocol, a way of accessing data from various internet sites. And those sites are running a data server that provides access to the information over a protocol that's technically called the DAP, for Data Access Protocol. It's not maybe the most creative name in the world, but I was younger then. So anyways, and what we want, and PyDAP is a Python implementation of that protocol. So our second notebook is actually going to look at a C implementation. So we're going to see sort of 2 different worlds. But what this notebook is going to do is it's going to show taking an OPeNDAP accessible data set. In this protocol, every data set is accessible using a URL. And this particular implementation of the data access protocol uses lazy evaluation, which is a technique that's very commonly employed in distributed systems. It's a way of making the logical flow of control appear to be very natural and top-down, but actually delaying certain expensive actions until they're absolutely necessary. And this can make it easier to develop distributed systems that perform well. So that is the sort of the gist of this notebook. We're going to take a URL that references a data set. We're going to open it. And by open it, what that means is talk to the server and pull a little metadata information about the contents of the data set, but not the actual data values. Then we're going to look at that stuff and we're going to choose a couple of variables and we're going to get those variables. And every time we get those variables, we're going to go over the network and we're going to pull just those bits of data back that we need. Then once we get them, we're going to do some finagling with them, because in reality, when data come out of a data set in a place like NASA, it's not all cooked. It's not totally ready for us to use. So we're going to modify it a little bit, and then we're going to make a simple plot. And the plot, I'm going to keep the plots really, really simple. We have a fancy plot at the end that you guys can play around with. But the thing is that this really isn't a plotting workshop. And it's an OPeNDAP workshop. And if you want to learn about plotting, I mean, actually, you'll see that there's actually more lines of code to make the plot than to get the data. So, okay, so here we go. So the way you run these Collab notebooks is you hover over one of these executable cells. So the cells in the notebook with the pretty big letters that are nicely formatted, you don't execute those. That's just for you to look at. These cells with the little arrow, you hover over that and you click on it, and it will run it. And the first time you click on one of these cells, you're going to get this sort of menacing pop-up. This is really too bad, but this is, I guess, the Google thing. They probably have lawyers too. And so you have to say, yeah, I'm all about that. And I don't know why it's saying this now. But anyways. It wants me to sign in. Seriously? No. I don't want to sign in. What was that?
Patty's logged in.
Okay, I have to change it to me. Oh, this is a drag.
Issue where they're saying it's hard to hear you, but there's an issue that Collab is Google
Yes.
and USGS federal employees aren't supposed to use.
Okay, well, I'll adjust that in just a second. Let me get logged in. Okay, so hold on a second. So there's an issue that some people can't use Google, and Collab is Google based, and so I've been running this from machines that were always logged into Google. So let's pivot. Let's use Binder. Okay, so we're gonna see how it goes. So go back to this window, go back to the main window, and in the readme.md, so go back to the top of the GitHub repo, and we're going to click on this launch Binder link right here. And we're going to see what happens. If you're logged into Collab already, you can just go with Collab. If you can't use Collab, go with this Binder option. And I think, well, we'll see how it works. But this is what Binder would look like if you're using Binder. So we're going to run the same notebooks. It's essentially going to be the same process. And if you can't use Google for one reason or another, you can go this way. I did it. Yes, I did it already. So let's let everybody get caught up with this step. And we're still going to click on the tutorials thing. But this time, instead of going down into, if you're doing this with Binder, click on the little folder that says Binder, not Collab. It's going to be essentially the same notebook, but it's essentially the same, but it's clearly not the same. And so we're still gonna run the same thing, which is the PyDAP 3 DAP4 basic tutorial. And the boxes that you click on are the same deal. In Binder, in Collab, you click on the little arrow off to the side. In Binder, you click on this play button up top, okay? But let me know when we're all there. And what I'm gonna do is that I'm gonna talk you through what's going on in these various cells so that you all kind of can use these on your own. You can use these on your own, whether it's with Google, Collab, or Binder. And actually, thanks to Chris here for getting the Collab stuff going, because I think, with a mix of people using both technologies, we have the highest probability of getting this working with our apparent bandwidth limitations. So we start running these cells, and the first thing that happens is we're doing some imports. So we're importing the request package and we're importing the PyDAP packages. Now, if you're familiar with Python, this is how you bring in Python packages so that you can write software with them. Requests is going to be used to make simple requests over HTTP, and we're going to see that also in the next notebook too. And then the PyDAP stuff, well, that's so we can use different parts of this Python implementation of the data access protocol. Some of these other things that we pull in just make the notebook look better or smoother, or let us show some metadata. So now we're going to log in with EDIL. Remember, we did that thing. We did that thing where actually, you know what? So I think with so with the Binder one, what you really need to do is there's another notebook that you need to go run first. I'm sorry about this. I'm a little surprised that that Collab had the hiccup it had. But so we need to go run the notebook called 0 first. And so we just go through and click those cells. And what will happen is we get a pop-up asking us to log in with our username and password. And so when you do log in, whether you log in Collab or whether you log in Binder, you'll get these messages on your screen that say things about a netrc file. And I'm going to explain a little bit about how Earth Data Login works behind the scenes. Earth Data Login uses a technique that was really designed for people to log in to websites. But when we work with programmatic access to data, we need to provide a way that the programs can get that authentication information and pass it around to machines behind the scenes. So what we do in this case is we write that information to a magic file called the .netrc file, which harkens from the early days of the internet when people stored their passwords in files. You're not supposed to do that, but that's what we're doing here. That's kind of the workaround for this technology. Then we're going to do another step. We're going to create something called a .dodsrc file. And this .dodsrc file is going to tell certain pieces of software, hey, you're going to go find a password in this .netrc file. So this is like a configuration for the DAP-aware software. And so what happens is you run this little shell script called setup .dodsrc, and it does that for you in this virtual environment. One thing about these virtual environments, what you're really doing is you're not really running the software on your computer, which is actually kind of good in this case because we know we have network bandwidth issues in this room, or probably this meeting. So it's really good that the heavy bandwidth traffic is going to be happening all in the cloud. That's where, and either in the case of Google Collab or Binder, your stuff is actually running on some other computer besides your laptop. And then, of course, we have to, then there's these other steps here that say approve the data and so on and so forth. You actually don't have to do these. We did these earlier because I just assumed that we were going to be using Collab. But here we are. Here we are doing this instead. Question?
I guess I'd like to point out that the dots are smile if you're on Collab gets created with.
Yes, it does. Yeah, so these steps in the Collab notebook, we migrated these steps into each notebook because in Collab, in Collab, each notebook runs in its own separate machine, and so you have to authenticate specially in each machine. Whereas in Binder, you actually get one machine, and you're going to be running the two notebooks in the same machine. So the authentication process is a little bit different. Like I said, Binder was our backup, just in case Collab didn't work, and Collab didn't work, not for everybody. So there you go. So much for virtualization, right? That's an actual problem, not a virtual problem. Question?
Unable to authenticate. If you're unable to authenticate, you have to create a netrc.
So if you need to be able to authenticate, otherwise the correct information won't go in the netrc file.
So in Binder, I'm not able to authenticate.
Can you double check your username and password?
Double check. I don't get it. I don't really understand.
I have a question regarding authentication. How far, I don't know if this is supported, but how far do you think the OPeNDAP protocol is from accepting authentication tokens instead of the...
Oh, so the protocol itself, so the OPeNDAP protocol itself rides on top of HTTP. So all of the authentication techniques that can be used with HTTP can be used with the protocol itself. So token passing is something that we already support in the data server that NASA runs. And that's also supported in the data server that you would get from our website.
So in theory, we could use this tutorial without writing our credentials into a netrc file, right?
We could, in theory, use it with tokens, yes.
Okay.
Yes, we could do that. Yes, exactly. So let me know where you all are in terms of logging in. I'm going to move forward with the PyDAP notebook. So I click on this cell and it says, I remember at the very beginning, long before we had learned how to log in with EDIL, at the very beginning I said that OPeNDAP thinks of each data set as being represented by a URL. So here in cell number 5 of the notebook, we see this, we see one of these URLs. And what we've done actually is we've designed this notebook so that you could either go to the Earth Data Login cloud, go to the NASA's cloud system, or you could go to a server that doesn't run in the cloud. And that's kind of an interesting thing, really. We're really talking about two dramatically different data systems, but we can work with them independent. We can work with them with the same essential software. So in this cell, the upper URL goes to opendap.earthdata.nasa.gov. And then we see some other things in the URL that tell that server how to access the data. And so the first thing is that we have this magic word collections, and then we have a kind of an opaque name, this thing that I'm going to highlight right here. And that is the collection concept ID that tells the server what data set it actually wants to look at. Now, one thing we could do is we can use tools in the Earth Data Cloud to look up and get collection concept IDs for different data sets. And we're going to show that in the next tutorial. Yeah, we got to get there, but we're going to do it. We can, but one of the things is you might look at one of these notebooks and say, well, James, how do I figure out what this thing is? Well, one thing we can do is we can cut and paste this, or we can copy it. Oh, let's not cut and paste it. Let's copy it, please. And so we're going to copy. Jeez. And we can go over to Earth Data Search. So we can go to search. I hope this isn't a mistake. Okay. Yeah, gotcha, man. From one James to another. So we can paste that concept ID into, how do you paste in this thing? Yeah, this isn't going to go. We're just going to go with a notebook. So anyways, you can look up these concept IDs in Earth Data Search, and you can find out that this is a GRIST SST subskin temperature data set.
In the Earth Data Search that you just were, would you mind clicking just like a random data product and showing where the collection ID lives, like Sentinel 1A? Yeah. So I find that. Where's that number I need to copy paste?
So what you wind up doing is you go in and you look at one of these granules and you look for more information on it. Actually, let me postpone that to the next one, okay? Because we have some pretty cool stuff in the next one, and I want to get there. So we're going along here, and what we're going to do is we're going to choose the top URL. If we wanted to, we could flip this use original service. We could set it to be false, and we could go to the OPeNDAP test server where the same data set happens to exist. This data set is from GRIST. That's the Group on High Resolution Sea Surface Temperature data set, and it's a subskin sea surface temperature, and that's actually what we're going to be looking at. So onward we go toward lunch. And so we set up that URL. Now, one other thing I want to say about these URLs, you notice that they don't begin with HTTP, they begin with DAP4. So a thing that most people don't really know is that protocol thing that you stick on the front of the URL, that doesn't go to the server. That actually gets consumed by the client software. And so the PyDAP application and a bunch of other applications understand that when a URL begins with DAP4:, that means, hey, use the newest version of the data access protocol to work with these data. So we keep on clicking on our cells, and this code here says, hey, if we passed in an HTTPS data set, turn it into one that begins with DAP4. It's just a way of enabling us to parameterize these notebooks and pass in more flexible URLs. But here, right now, this is where we're going to actually do the things that this workshop is about. So we're going to call this PyDAP open URL call, and that's going to open the data set. And so it's going to take a little bit of time, and you can see that the little asterisk here shows that it's working, and it comes back and it says, hey, I'm done. So it's transferred a bunch of metadata about this data set into the notebook. And it's printed out this helpful thing because I'm a programmer and I think that Python dictionaries are actually helpful. For most people, this is not very helpful. Instead, this is confusing and annoying, but there you have it. So these are all the Python dictionaries that are brought over. So one of the really nice things, though, that I wanted to show about this is that we've brought information from this data set into this very Pythonic representation. And people who program in Python know how to use dictionaries. And there's lots of software that consume dictionaries in the Python ecosystem. So now what we want to do is we want to be the people who read some values. So first off, we might want to find out the sorts of variables that are in this data set. So we can use print, and we can print the PyDAP dataset object, and we can see that there's wind speed, longitude, original longitude, time, standard deviation for sea surface temperature, a bunch of different variables in this data set. And what we're going to do is we're going to print out some information about just a handful of those. We're interested in sea surface temperature, and so I worked for a while in an oceanography lab where sea surface temperature ruled the roost. So here we do, and so this comes back immediately, right? We're not going to the server for these things. This is the information, the metadata was brought over in the initial open call. We opened it, even though it's actually stateless, but anyways. And so we go down here and we keep on running these cells, and I'm just clicking through. But at this point, what we're gonna do is we're gonna get some data. And again, remember that PyDAP does this thing called lazy evaluation. So lazy evaluation, again, that means that we postpone activities until we really need to do them. And that helps make distributed systems function better, because sometimes the best way of organizing a particular series of operations is not the way that is the most logically convenient for us to note. So, but now what we've done is we've gotten this variable called time, and now we're going to go get latitude. And so these are the coordinate variables for this array. And latitude takes a little bit of time. So some of these things, even though they're not moving very much data, they take a couple seconds. And in fact, I'm going to risk it all, and I'm going to modify this cell a little bit so that the next cell will print out the time that it takes. And you guys can modify, you guys can modify these cells in the notebooks that you're running, either in Collab or Binder. You can hack these up all you want to. It's not going to affect anybody else. You're each running your own copy in your own virtual environment. Question? Okay. Yes. It does say HTTP. That's interesting. Well, we are ultimately using HTTP. So once you get inside the cloud, inside NGAP, we do move things with HTTP, I think. But you know what? Okay. Well, there you go. Oh, but hey, so I modified this cell so that we get the time information from it. So this is a Jupyter notebook thing. You can say % time, and then you get the time execution on the cell. So it took 4.84 seconds to get the latitude vector back. So what's going to be kind of interesting is how much time it takes to get the whole SST array back. Is that going to be a lot longer than 4.4 seconds? So this SST array is 3 orders of magnitude bigger than the longitude array. And so let's go get that and see if it in fact takes 4,000 seconds. And presumably it's not going to take 4,000 seconds, because that would be sad for this tutorial, wouldn't it? But it didn't. It took 8. So like, how is that possible? How on earth could we get 1,000 times more data in only twice the time? And so the reality, this is a reality of cloud computing systems, which is kind of not part of this tutorial, but I might as well tell you about it now, because here we are, right? When you transfer large quantities of information in a single request, it moves much more efficiently than when you make many small requests, because cloud systems have a lot of latency associated with each request. So are people familiar with this concept of request latency in data systems? Yeah, okay, so you're kind of with me on this one. So this is a depiction of what's really going on when we talk about latency in these data systems. So now what we're going to do is we're going to take that sea surface. So now we're done. We're done with OPeNDAP, okay? OPeNDAP is now pretty much going to be out of the picture, but I'm going to make a plot out of these things. So we're going to modify these values a little bit. So the first thing we're going to do is we're going to squeeze the SST array so that instead of having 3 dimensions, the outermost one of which is 1, we're going to turn it into a 2-dimensional array. And then we're going to convert it from integers to floating point numbers. And that is going to set the stage for the next bit of excitement. And in the next bit of excitement, what we're going to do is we're going to look at it. And so we're going to see what this stuff looks like. And one of the things we see is that we got a whole bunch of NADA numbers in here. And then we have these other things that look very peculiar. They don't really look like sea surface temperature unless we're like on a different planet, right? Because 1513 does not seem like the sort of temperature one would expect in the sea. But we do notice when we look at this data set that its units are degrees Kelvin, right? So, okay, but still 1500 is a lot. But we also notice that there's an offset of 273.1499. Well, that seems peculiar, but 273 seems reasonable, doesn't it? And there's a scale factor of 0.01. So, okay, let's apply that scale factor and add offset, right? That's y equals mx plus b. That's not an uncommon way for data to be scaled. And in fact, if we go around and we poke in at this data set a little bit more, we'll find out that it uses a set of conventions called the CF conventions. And the CF conventions oftentimes scale their data using y equals mx plus b, and they store m in scale factor, and they store b in add offset. I'm going to keep it as 0.14999, even though it's almost certainly 1.5, because, you know, this is a demo. but we'll be using the same data set in the next one as well. And so when we scale it and then we print it out, it looks a lot better. It looks like the temperature values one might expect. 288 degrees Kelvin, that's about what? 14, 15 degrees C. That's a reasonable sea surface temperature. So let's plot it. So to plot it, we're going to use the excitement of CartoPy. And for you guys in Collab, since the Collab stock environment doesn't include CartoPy, you're going to see a bunch of pip commands that go pull data in. And for binder thingy was set up with Collab already. So you get these menacing messages about it downloading things. But remember, that's not happening over our little Wi-Fi. That's happening back in the cloud where binder runs. Okay. And then, thanks to Chris, who provided this wonderful plot. So remember, I said that this is not a plotting tutorial, but we do have wonderful plots here. And one of the things you notice is, these are the commands that were required to plot this. And there are actually more commands here than were necessary to get the data. So that kind of shows you that from the perspective of data access, OPeNDAP is pretty easy, and it enabled us to subset these data pretty effectively. So I'd like to go on to the next notebook because it talks a little bit more about how OPeNDAP lives in the collection of things that are part of the NGAP cloud system. And we've got about half an hour left. So let's go there. And so we're going to go to the DAC tutorials folder. So go up to the top and then click on DAC tutorials. And this is going to be true for those of you that are doing Collab or Binder. And I'll wait for folks to catch up with me there. Yeah, actually, we should pause for a check-in to make sure that y'all are still with me.
And how you're feeling and any comments, reflections on your experience so far?
Okay,
so James, just in terms of how you're positioning this in the audience in the room, is this level or this way of accessing these resources the way that this group should take these things away? Because this is the technology that makes it work, but there are layers of software that have been written to make this all a lot easier.
Yep.
So this is how people should be doing it?
Well, this is one way, for sure, yeah.
Okay.
Yeah, I think so. I mean, so this is a way that gets you out from being hidden. Like, for example, we had one person say, I use Appears a lot, but I really want I want something that's a much more integratable into my own workflows, and I want to be able to make my own workflows. And this is a technique for that. Now, there are other systems like Appears, Giovanni, and Harmony. All of those systems use OPeNDAP under the hood to get data, but they hide the actual operations from you. Okay. Maybe we can talk about that more. Okay. Other question? Comment?
A little bit of a follow-up. Maybe what you were saying, I don't know if is like in this level of, and I think this notebook has that, the higher level. I saw the X-ray, and that's probably what he was kind of asking, like, oh, you could use not just the DAP and PyDAP directly. That's for power users, but also you could like create your PyDAP store and use X-ray on top of that. I guess that's what.
Yep. Well, actually, that's what this notebook is about. So so now what we're going to do is we're going to shift gears a little bit. And we're going to show how OPeNDAP is a bit more integrated into the Earth Data Cloud. And so this notebook is going to combine two different things. The first thing it's going to combine is we're going to take a DOI to a data set, and we're going to look that up in a database called CMR, the Common Metadata Repository. And we're going to use the information from CMR to get those OPeNDAP URLs. So that's one thing we're going to do. And there's some other things that are hinted at and are shown in the notebook as well, with respect to looking for data sets and getting. Remember, we talked about those concept IDs. So we're going to show you how you get those without knowing them a priori. And then the next thing is we're going to use a tool called Xarray. And Xarray is a really powerful tool for pulling data over the network. And Xarray is capable of working with OPeNDAP. In this case, we're going to use Xarray with the netcdfc library, which is a really powerful tool. It comes from Unidata, and it is capable of reading data not only from netcdf files on disk, but also you can pass the netcdfc library OPeNDAP URLs, and it will dereference that information. And it does things a little bit differently than PyDAP. It doesn't do all of the lazy loading things that PyDAP does, but it does most of those things. And we can work with the Unidata developers to kind of tune its behavior. So that's what we're going to see in this notebook. And I'm just going to click through some of the early stages. If you're running this in Binder, it's going to be binderized for you. And so you just kind of click through it, and it will say some things like this pip install business. It's just going to say that requirement has already been settled. If you're in Collab, you're in a totally new virtual machine, and so it's going to go get a bunch of stuff for you. And this is where my phone goes off. That's why doesn't it go off other times? And so now we get down to this point where we do these imports. So this is again the same sort of thing as before. Earth access is how we're logging in with our EDL account. Some of these other things just make the notebook flow a little bit more smoothly. In this case, in the previous notebook, we loaded the request package, but we didn't actually use it. And this one, we are going to actually use the request package to talk to CMR. So we go through and we do the auth thing, and I'm going to type in my password once again, my username and password, my magic one. Yeah, sure, I will. Hold on a second. You go up to the DAC tutorials and click on the very first one you see there, whose name begins with Earth Data. And what you do in order to run it as a Collab notebook, if you scroll up to the beginning, there's an Open in Collab badge, and you click on that. So if you're using Collab, that's how you do it. In Binder, you can just skip over those things. All right. Okay. So again, binder, you log in, you get your stuff. And in this one, we actually do the creation of the .rc file in Python code. In the earlier notebook, we did it in Bash code. Now we're doing it in Python, so you can see it each way. This notebook, by the way, I should credit the authors of this notebook. This was written by folks from the Oak Ridge DAC. So Michelle Thornton, and I'm probably forgetting a bunch of people. But it's, like I said, it's pretty cool in the things that it does in addition to the OPeNDAP part. Of course, the OPeNDAP part is the coolest part, but that's only because I'm paid to tell you that. So after we do our logins, we do the imports for more things. And you notice here, we're not importing PyDAP, instead we're importing Xarray and we're importing netcdf4. And so onward we go, chugging along. And here we have a DOI, and what we want to do, we have a DOI for a data set. So imagine that we're reading a paper and the paper cites a data set with a DOI. And we say, well, wow, I wonder, oh, look, that looks like sort of a NASA DOI. So we can look that up in CMR and get the information we need to query CMR to find out some data. So let's do that. And so here we take the base URL for CMR, which is this one right here. This one right here, which I'm going to highlight, which is cmr.earthdata.nasa.gov/search. And we're going to put in the URL, the DOI, which says ORNL DAC, which is our big clue that this DOI came from NASA. And we're going to put in this query, which says collections.json DOI equals. So we build the URL using the Python string concatenation operation, the plus sign, and we're going to use requests, and we're going to go get that thing. And that's going to be a big, messy JSON document. And then we're going to subset the JSON document using this fancy JSON subsetting expression. I'm not going to go through and explain JSON subsetting because we don't have time for that. But it's not that hard. And somebody's got a question.
Yeah, so the library that you're using?
Yes.
The library that you're using for authentication can do that too.
Oh, great.
So
okay.
It could be a line of code too.
Ah, great. Great. And you are the person who wrote the library we are using for authentication. So he's a plant. Okay, so now here's what we're going to do. Now we want, so we've got this information that's going to enable us to make another request to CMR. And so what we're going to do is we're going to try to find the specific files, the specific granules for different date ranges. So we're going to start with a starting date of 2010, January 1st, and we're going to go all the way to 2011, December 31st. So again, all of this cell right here that I'm hovering over now, what it's going to do is just make a date string for us. And these are just Python commands that fill around with date values. This is some of the fabled data wrangling that you hear data scientists talk about. We're wrangling dates now. And what we're actually doing is we're making an ISO 8601 date range. Woohoo. And so onward, we've made it. And that's this wonderful thing down here that looks, well, like dates and times. And so we can keep on going. And now in this cell, in this one, we're going to actually make a request to CMR. And this time we've gotten the concept ID from the DOI. Remember, we did that previously. And so what we're going to say is, hey, we're going to make a temporal request. We want it paginated, so we're going to get the responses back in lumps of 200 responses each. Let's hope we don't get more than one of those, because 200 is a lot. And we're going to extract from that the feed and entry information, and then we're going to print out what we get. So let's do that. And so off we go, and we print out this collection of URLs. And so now you notice that they all begin with HTTPS, And, but look, they say OPeNDAP, earthdata.nasa.gov. And in fact, actually, I think if we click on one of these, we're probably going to get an error. But but we're going to do it anyways, because this is a workshop and we're cool like that. So now we can do this and we're cool like that. Good Lord, that sounds pathetic. But we can take and we can tack on the end of this URL, the magic 3 letters DMR. And if we do that, we should get a response from the data server. And so we do. And so this is coming directly from the data server that reads data out of the cloud. And this is another way that you can use OPeNDAP. This is even lower level than the other things we did. But you can do things like you can look at the global attributes, you can look at the dimensions, you can make queries of individual things. It's kind of cool. Okay, but let's go back to our notebook because we're going to run out of time. So onward we go. So now we've got this. What we want to do is we want to say, let's get some data from this. Now, this is where I have to own up. I'm not a super Xarray developer. If I was a super Xarray developer, and this was a particular tutorial about Xarray and Dask, what I would do is I would use Xarray with Dask to do parallel access, and I would pull data from all of those granules in parallel simultaneously. But it's not that demo. So what I'm going to do is and this is not that notebook, okay? So what we're going to do is we're going to get data from the first of those URLs, and let's take a look at the URL. This keeps popping up like this. We're going to take a look at the first of those, and this is DayMet data, and it's for Hawaii. That's what the HI stands for. And so it covers the Hawaii region. And so onward we go. And this is the part in this show when we actually get some data. And so this is Xarray doing these operations now. And what Xarray is going to do is it's going to do a lot more work than PyDAP did. PyDAP just moved the bytes over, okay? And then we had to fiddle with them. Xarray knows that these data are in CF 1.6. It knows that these data need to be fiddled with. And so it's going to treat these things like sea surface temperature as Xarray data sets. And it's going to provide all of that data wrangling stuff for you. So it operates at a much higher level. It understands these metadata conventions that are used with these data. So that's come back now. So now what we've done is we've moved that information into our notebook, and we can take a look. Xarray provides this sort of snazzy display, so we can see the coordinates. See, the coordinates have already been turned into floating point data. We can look at the variables. There's temperature max, and so on and so forth. We can look at the indices. We can look at attributes. These are pretty nice. You can hide and show them. Xarray is a very impressive piece of software. But onward we go. And what we're going to do now is we're going to do it all over again because I clicked on the wrong thing. Classic. Okay. So we're getting it again because I clicked on the wrong thing. And it's kind of a downside to these notebooks. I have to say they're a little fiddly. But anyways, so now what we're going to do is we're going to use Xarray to resample that particular data information that we got about Hawaii and its monthly maximum temperature, and we're going to get the mean, or rather we have annual data and we're going to compute the monthly mean. And so Xarray does all this stuff for us. It says, okay, for this data set, get the Tmax variable, this line right here where I'm hovering over, resample it using the monthly mean. So time equals M is monthly, and then dot mean is the mean, right? So we're going to do that now, and it actually takes a fair bit of time. It's going to take it a few seconds to do that. Again, if we were really slick, we could do that in parallel. We could use Dask possibly to carve up these data into, say, 10 chunks, 16 chunks, and run that mean operation in parallel. But This really isn't a Dask tutorial. I think somebody in the cloud optimized data group yesterday said, Dask is so complicated that we formed this whole other software layer to deal with it. Yeah, okay. So the monthly mean is being computed now by the notebook code and well, by Xarray, but it's running in the notebook. And when we get that, we're going to plot it and see if the data look like something we might be interested in using more. And so Xarray comes with pretty nice plotting code. So we're going to slice out just 1 month. So we computed, remember the month, we went monthly, and we computed the mean. So we've gone down from a 365 by 500 and 200 array. We've gone down to a 12 by 500 by 200 array. And the 6th slice is going to be July. So we can plot that. And Xarray has a plot function. It's pretty savvy because remember, Xarray knows about the metadata conventions and everything. So again, metadata, the Xarray is a much higher level than PyDAP. So we don't have to do all the manipulations ourselves. So again, here's the same kind of information, and you see its temperatures are degrees C. The values have been already converted for us. We know that they were pulled out of the file as integer values, but they got converted into floating point numbers behind the scenes. So Xarray is a higher level interface in this case, and also it can be a higher level interface that enables parallelization through a tool like Dask. So that's the second notebook. So there's another notebook in this collection that's also contributed by the DAX that Chris wrote that uses Meridata, which is a reanalysis product. And there's a few other notebooks in the tutorials section that talk about just using NetCDF by itself. And there's another one in there that talks about using Xarray by itself. And there's a final notebook that talks about working with DAP2 from these different kinds of servers. And the OPeNDAP notebooks all have this sort of bimodal operation. You can choose to use the data server that is the OPeNDAP in the cloud server, or you can go to the test OPeNDAP server, so you can see it functioning in these two different environments. And then finally, the Mera notebook that Chris wrote goes to a NASA on-premises server that runs at Goddard Space Flight Center. So we're trying to sort of have notebooks in this collection that cover some of the different bases for how you might actually get these data, because not everything is in the cloud now, and not everything is NASA either, right? I mean, one of the things about OPeNDAP is it's a protocol that's supported by several different groups. Unidata has their implementation of it. The PyDAP implementation is actually independent of both Unidata and OPeNDAP. And there's a server that runs at Columbia University as well. There's another server that's maintained by NOAA. So there are many different organizations providing information using this protocol, and you can mix and match them in these notebooks. So anyways, are there any questions? Thanks.
We'd also just love to also just hear feedback about how these tutorials felt for you guys. This is a little bit, it's one of the first times that we've done them, and we want to improve them. So please, any feedback would be really welcome, and we'd love to share contact information as well.
You have a question or feedback?
Both, actually. So I'm Steve Formel from USGS. The first is that, especially apropos to this conference, I feel like this whole suite of notebooks could benefit from maybe becoming a carpentries episode or lesson where they're stitched together in different episodes, and could benefit from just the carpentries pedagogy in general. But I'm sort of everything made sense today, and thank you for taking the time to show me. But I think something that's not clicking for me is I'm not understanding what is the advantage of using OPeNDAP compared with like working with other APIs, because this felt very similar to just calling data from an API or through an API. And so is the advantage of OPeNDAP to the user, or is it really more about having like a standardized sort of, infrastructure for the people who are serving the data?
Well, it's a little bit of both, but it definitely standardized infrastructure for people who are serving data is a really important thing. And that it was part of the original notion of forming OPeNDAP in the first place. It was actually OPeNDAP started as a research project. It was sponsored by NASA in its earliest forms. It was called the Distributed Oceanographic Data System. And the problem that we were initially trying to address was the fact that oceanographic researchers working at universities were building their own versions of data sets that NASA was hosting. And those people wanted to make them easily available to their colleagues without a whole lot of heavy lifting. And so we developed OPeNDAP. And then what happened over time is that OPeNDAP became adopted by many of those large organizations like NASA and NOAA, and USGS runs an OPeNDAP server, EPA runs OPeNDAP servers. As I said, Columbia runs them. They're pretty common, actually. And so the large organizations are using them, and they're using for a lot of the same reasons, because they make it fairly easy to make the data accessible. So one of the things, the other thing is that a data server like OPeNDAP provides you with a view of the data that gives you a sort of a homogeneous logical model. It breaks the data down in the same sorts of ways that self-describing APIs do, but it can shield end users from the actual organization of the data by presenting things that are slightly different. And this is particularly the case when NASA uses it, because NASA's HDF5 files, even though when we talk about it, we say, oh, it's an HDF5 file, as if HDF5 is a format, but it's not really a format. It's a tool for specifying a family of formats. And there's considerable variability between different HDF5 files. Then the OPeNDAP server in the cloud has been specially tuned to recognize certain variations between those files and sort of homogenize them to present this CF 1.4, 1.6 compliant view of the data. So it's kind of all of those things. And so does that benefit the data provider or the data user? Well, I mean, I think that's kind of up for you all to decide. Yeah. Question, comment? And I know there's a comment over here in the front.
So this may reveal my ignorance here, but what is the difference between OPeNDAP and like STAC?
So STAC, Spatiotemporal Access Catalog, yeah, is was initially a cataloging system. And it was designed to be a collection of linked catalogs that would help you locate data. And so what stack catalogs do is they mix in a combination of data location metadata and data use metadata. Primarily, they're focused mostly on data location or the description metadata. But stack has been combined with Python intake. And so that has made it more of an accessing tool or something that can drive code that accesses data. So there is overlap in a lot of these things. And another commonly used technology that pops up in context with Stack is ZAR, which is a specific format that's designed to be more amenable to cloud-based data stores. ZAR uses a technique called sharding, which takes data that are held in a single object or a single file. And in this context, the words object and file wind up being the same when we talk about web object servers. And instead of holding it in a single object, it breaks it up and stores its different components in separate, individually accessible objects. There are pluses and minuses to those techniques. Sharding is a commonly used technology in relational databases and other data systems. Comment. You've had your hand up for a long time, but you've got the microphone, so why don't we just go there and we'll get it over to you.
Thank you for this workshop. I thought it was fun and informative. Small feedback I thought would be I'm not there yet as a user, but if I got more comfortable, I would appreciate seeing those blurbs you're mentioning about, if I were Xarray and Dask savvy, I would do it like this.
Yeah.
And I would put that as like little italicized footnotes or something.
Oh, okay, cool. All right, great. Okay, our extremely patient participant, who's also named James.
Thanks very much. So I want to make sure I understand that the use case for where OPeNDAP as a technology or a layer still shines and we should be used, and where it doesn't get used. So a lot of data moves to the cloud, right? So if you're doing something in the cloud and you've got direct cloud access, should you still be using OPeNDAP as the protocol or the interface through it? Like I'm thinking back to a date and a time where to get data, you had to connect to a server, some thread server or whatever that might expose an OPeNDAP thing. And we needed that. But if all the data is up in the cloud and I've got direct read access to the buckets, do I still flow through OPeNDAP as the best practice?
Depends.
Okay.
If those data that have been pushed to the cloud were just pushed as HDF5 files, you probably do want to use something like OPeNDAP, because you probably don't want to see all the weird things that are actually inside those files. If, as they were moved, like suppose they were pushed to the cloud and they were turned into cloud optimized HDF5. So OPeNDAP servers can work with cloud optimized HDF5 really, really efficiently. So that's a good thing. But suppose they were turned into ZAR and it was just straight away, then you probably would like to see some of the homogenization, the metadata homogenization that a data server brings to the equation. I mean, this is essentially the question of, do I want to specifically organize my data set for a particular algorithm? Or do I want to have a generalized database that can treat a wide variety of algorithms? And the notion of a data server is that it makes this logical data model that can serve a lot of different potential uses. Whereas cloud optimized files oftentimes wind up being optimized not just for the cloud, but also for specific use cases. Exactly, it is nominally a more generalized interface. Cool. Okay. Well, hey, thank you very much. Interesting, huh? So what did we learn today? What did I learn today? I'll tell you what I learned today is that Collab and Binder, neither one of them are a perfect solution. I think we learned that Earth Data Login. Yeah. Interesting, huh? And so, you know, one of the things I mean, I know I'm keeping y'all from lunch. I'm keeping myself from lunch, but I live off coffee. So anyways, but what do you guys think about the logins? I mean, like, do you think, wow, that should maybe go away? Or do you think that's a really good thing? I'll tell you, but before we have this discussion, I have to tell you that as a person who reports to the board of directors of this nonprofit, it's really important for me to be able to tell them that at NASA, we get 500,000 accesses a day. That really makes a big difference. And we don't know what happens at the servers that run at Columbia University or these other places. We have no idea what's going on. So for me to be able to talk about the level of access that happens, that's really important. But then I saw in this workshop that we spent half the workshop getting logged in. Oy. You know, I mean, we could have done, I mean, we knew this was going to happen, kind of. I mean, we didn't know exactly what was going to happen, but we knew that we were never going to get through 6 notebooks, right? Although we should have been able to at least get another notebook in, you know, at least maybe a plain X-array notebook or something like that. So I don't know. Talk to your congressman.
Login stuff been, could some of that login stuff been recommended as pre-work? Granted, we're not all reading like, hey,
The
to be
emails.
ready for the workshop.
I did actually send out an email. I think I said that, but yes. So
Maybe I wasn't
but you know,
signed up for this early enough.
You know, honestly, I never read those emails either.
I read the emails.
Yeah.
And also like over your session, if the learning objective is
Yeah, that would. All I really, you know, I just wanted to show you guys, really I wanted to show you the PyDAP stuff and I wanted to show you how its lazy evaluation works, and I wanted to show you an example of Xarray and NetCDF to show you that there's this other technology. There's a couple of different technologies that you can pick from, and we've just scratched the surface. There's lots of other ways. And then I wanted to show you these simple plots so you can get a qualitative feel for the information you're accessing. That's primarily it, and I really like the fact that in the DAC authored catalogs, you're using things like CMR and stuff like that, you know.
One of the things that you mentioned is the fact that OPeNDAP kind of hides the complexity of the underlying files, and I think that's the great feature of OPeNDAP, because one of the things that I run into is that even for HDF5, you can find ways of working with it, but
Sure.
a lot of the most popular data sets are not even in HDF5, they're in HDF EOS.
Right, which is actually HDF4.
Yes.
Yes, indeed.
So that's very unusable in the cloud.
Right, right.
And at least OPeNDAP offers kind of an avenue, right? Like, okay.
Right, right. Yep. I think we should be done. Thank you all. I really appreciate your attention. And thank you, Erika, and thank you, Chris, for being here.